Buffers are solutions that resist pH change. If you think about how we use the word buffer in everyday life, a buffer is kind of a sort of a cushion between two things, right? And so a buffer cushions pH changes. What makes a buffer is a solution that contains significant amounts of both a weak acid and its conjugate base. It can't be a strong acid. A strong acid does not act as a buffer. It has to be a weak acid. So you've got the weak acid and the conjugate base present. The weak acid will neutralize any base that's added, and the conjugate base will neutralize any acid that's added. And so whether you put acid into the solution or base into the solution, it will neutralize it and maintain a pH. So buffers are very important in physiological systems. Your blood has a buffer system in it because the pH needs to be between 7.36 and 7.40 in order for you to be healthy. If it gets much outside of that, below 7.0 or above 7.8, you die, right? So this buffer system is really important. Acetic acid, sodium acetate, makes a buffer system. So acetic acid is a weak acid. It's not one of the 6 strong acids. Anything that's not one of those 6 would be a weak acid. Its conjugate base is sodium acetate. So we've got acetic acid present. We also have acetate present. If we add a base like sodium hydroxide to this solution, the acetic acid will neutralize it, becoming sodium acetate. If we add acid to this solution, the acid will react with the weak base and neutralize it and form acetic acid. So let's look at a picture version of this. So here's our beaker of our buffer solution. So we have acetate ions and we have acetic acid ions. This can only happen because it's a weak base. So we've got a weak acid. We have a weak acid and the conjugate base. So if you add acid to it, the acid will react with the conjugate base and be neutralized. If we add hydroxide to this solution, it will react with the weak acid and become neutralized. And so the pH doesn't change. Any questions about that?
It's kind of a lot to kind of understand.
It's a lot to take in. Yeah, it is. So I just need something to write on. Not that. So let's think about acetic acid, right? HC2H3O2. When we put that into water, it will donate the proton, right? Because this is an acid. It'll donate the proton to water, and so we'll get H3O plus, and then the conjugate base is the C2H3O2 minus. So this is our acid, and this is the conjugate base. The conjugate base is what you have after the acid donates its proton. So it's passed off its proton. Now it's standing around with empty arms, and it can act as a base because it can take a proton from somebody else. Well, I passed off my baby to somebody else, but I'll hold your baby now, right? It's just pass the hydrogen ions around. So we've got the acid and the conjugate base in the same solution. If we add base, the acid will neutralize it. If we add acid, the conjugate base will neutralize it. Now, when you show the formulas for the buffer, you don't say, oh, well, we've got acetic acid and acetate ion. Because can you have just acetate ions? No. There has to be a cation with it. Does it matter what cation it is? No. because the net ionic equation that's happening is this. But there's got to be some other ions in there somewhere. So that's why it says sodium acetate. So we don't care about the sodium, but it's the fact that we've got acetate here. We need significant amounts of the acid and its conjugate base so that it can go either way. So let's look at this question. Which of the following is a buffer solution? And this is about the extent of what would be required of you on an exam.
So when the acid is too strong, right, for A?
For A, yeah, we've got H2SO4, that's a strong acid. And what is this?
A base, a weak base?
No, but it's also an
A
acid.
weak acid?
It's a weak acid, so we have a strong acid and a weak acid. Does that fit the formula?
It's stronger and weaker because
This is
there's
a,
more ion?
no, this is strong because it's on the list. That's, yeah. So there's some things that I can, explain to you, and there's other things it's like, well, it's just because it is. So there's H2SO4, HClO4, HNO3. Those are the ones that seem a little just random. And then there's the halogen acids, HCl, HBr, and HI. HF is not on here. HF is a weak acid. So, I've talked about the halogens as being sisters, right? Well, fluorine is the smallest one. She's the baby sister. She's a weak acid. She's not very strong because she hasn't grown up yet. She never does grow up. Been doing this for years. She's still a baby. These are the strong acids. And how do you know they're strong acids? You memorize them. There's stuff in life that you just have to remember. And if you want to be a nurse or a doctor, you're going to have to memorize so much stuff. It'll make this seem nothing in terms of memorization. So this is a strong acid, this is a weak acid. Is that the formula for a buffer? No. We need a weak acid and its conjugate base. So this is a no-go. How about this one? HF and NaF. Here we have an acid. We can tell because it starts with H. It's not on the list. This is a weak acid. And then we have to ask ourselves, is this the conjugate base? Yeah, it is. So that sodium there is just a spectator ion. If I get rid of the sodium, the ion I have here is F minus. And so what I'm doing is I'm comparing these two formulas, HF and F minus. Do they differ by one hydrogen ion? Yes, they do. This has one more hydrogen ion and one more positive charge than this does. This is the conjugate base of that weak acid. So there we have our winner. But we better check the others because this isn't an exam question. It's possible there's more than one right answer. So here we've got HCl and NaCl. Is this a buffer? No, why not?
Because it's a strong acid.
HCl is a strong acid. This is the conjugate base. But this won't act as a buffer because when hydrochloric acid is dissolved in water, it ionizes completely. So yeah, you've got chloride there, but the chloride is not going to recombine with hydrogen ion. It's not going to neutralize anything. Strong acids do not make buffer solutions. What about this one down here? No.
They're both bases, right?
Well, one's a base. You could think of this as the conjugate base of HCl. We don't have an acid. So there's good, deep levels of understanding, and then there's the enough clues to get the answer, right? And for Chem 3A, just having enough clues to guess the correct answer will get you through, right? So when you look at this, there's no acid in that. So you don't even have to think any further. That can't be a buffer because there's no acid in there. We can tell that because nothing starts with H. You got to have something that starts with H that's not on the list, and then you have to have the conjugate base. Any questions?